Hello everyone, this is introduction video about comma flow and about all this stuff that you're gonna see later. Let me do fast introduction about this project. It's full stack Web3 architecture. You're gonna have all this code open source. I will open this when I do last fixes. I already did some fix. If we update, you're gonna see new commit here. I already recording all videos that you're gonna see in this cycle. And this comma flow is just architecture where you can create full stack project, like fully full stack, from Solidity contracts to frontend, and with subgraph and backend indexer and REST API. We're gonna use Solidity, subgraph, like you need to know TypeScript, JavaScript. For backend also we're gonna do it on Node, and React, it's also this stuff. So from interesting part here, on Solidity contracts it's not gonna be just ERC20 token, it's gonna be UUPS ERC1967 proxy upgradable token. It's gonna have blacklist, and it's gonna have possibility to mint, to do some custom stuff with this token, like burn, etc. So you're gonna see it all in videos that gonna go after this introduction. All code in description, all introduction is okay. Let's go. Hello everyone, in this video we're gonna speak about Solidity smart contracts, but not usual ones. We're gonna speak about proxy 1957, or I forget numbers, but it's UUPS, it means it's upgradable proxy contract. I will show you how it's gonna work for you, because just ERC20 protocol is like lame for us now. You can check my another videos where I create these tokens with just ERC20. But now we're gonna check something more difficult in the token creation. Besides this proxy upgradable contracts, there's gonna be a change of roles like minter, admin, etc. You're gonna see all this. So you can find all code in description. I think it's gonna be full open source. You see, it's gonna be part of my full stack Web3 architecture, like comma flow. Yeah, it's called like this. It's gonna be architecture like Solidity contracts that we create now. Then I will show you in next video subgraph, then backend indexer and REST API, how you can create backend service for subgraphs, so you can just index this time to time. And we will connect all this to frontend, where we can mint our contract, burn tokens, and check actual dashboard. Like it's gonna be separated by roles. If you connect like admin, you're gonna see admin roles. If like minter, you're gonna see minter actions and roles. So let's go to Solidity contracts. Let's go. Okay, we now in our code play, in our comma protocol folder, in our comma flow. And I already write readme for you for installation process if you want like to do it fast. I will review all this code so you can understand what's happened, not just install it blindly. By features I already said that it's upgradable ERC20 by ERC1957 proxy protocol. We will see this protocol later. I just forget these numbers. It's hard to like always have it in our head. Role-based minting, blacklisting, it's another feature that we're gonna have. We can blacklist users. It's gonna be on Arbitrum, Cipolle +1, but it's not a lot of like problem for us. You can deploy it on every Ethereum chain, not only Arbitrum. Subgraph and backend ready. Yeah, it's gonna be next our videos. So by installation, let's first imagine you just go into this repo. First that you need to do is install all these things, like by Forge. Yeah, we're gonna use Forge in our way. Like if we're gonna check, we're gonna use Foundry Toml. You're gonna just copy my repository, so you don't need to set up it from scratch, from some scratch template. But if you don't have Foundry, you need to install Foundry. And if you use Windows system, you need to have a Ubuntu distribution, like to actually interact with Forge. I don't know if it's if they have Windows fully support, but if they even have, it can be a big of a problem. So I recommend you to use VSL terminal. anyway. Yeah, and here you can see that we're gonna use all these parameters. We're gonna use Arbitrum Cipolle in our way, because I don't want to deploy it with real money, but you can just change to real Arbitrum one. I already have a funny bug, I will show it later. I don't know how it's like possible, but it's a bit, it was a bit of problem when I developed with my Arbitrum 1 and Arbitrum Cipolle indexation, like, because blocks was different. I will show it later. Now, if we check our readme, we can just, let's imagine that you already have Forge, we can just Forge install all these libraries. You can find these libraries in remappings. It's all that we're gonna use, like OpenZeppelin and some of this upgradable proxy, and just contracts for OpenZeppelin. It's like a classic way for Ethereum smart contracts use OpenZeppelin. So you install this all this stuff, and then you can build, but first we're gonna check what smart contract is. We're not gonna build it blindly. I already write smart contract, but yeah, let's check it with you. By the way, you need env example also. You can find it in readme or in my code. I'm not gonna show real env because it's my private key there. It's from dev account, but still, like, even 10 bucks, it's 10 bucks, you know. So in private key you just need to replace your private key wallet with wallet what you're gonna use for deployment. It should have some Arbitrum Cipolle tokens. You can find it in Arbitrum Cipolle full set. Let me show you. You can use Alchemy. I guess I don't need to sign up, but I have account there. I'm not sure that I need to sign up for like DevNet. You can choose in like MetaMask, copy your Ethereum layer. I'm not sure what wallet you use, but it's like a simple process if you're already in advanced position. You can request 01 in Arbitrum Cipolle, but actually why I can't request, I guess because I'm not signed in. Give a sec. Jesus, okay. It's impossible. Okay, Alchemy always like have a long ways. Let's check it on Arbitrum face faucet quick note. And login into for Forex bonus. No thanks, just send me 005. Like here you don't need some login. Transaction inquire for my address. For now we have yeah, it's just updated by when I open this. You see it's correct. Okay, good. Transaction inquire, but I see that it's already good. Verify I'm human. Yeah, you also can use Alchemy, Cipolle faucet. Finally I log in. You see if you sign in you can get this token. Or it was some bug because I don't get Cloudflare. And you can use also Chainlink, but here you need some links sometimes. So I'm not sure that you can do this here. Okay, next let's go to code again. We get our Cipolle tokens. It means we can deploy our Cipolle Arbitrum contract now. But before deploy we're gonna check it further. Let me now do this. And in the example I want to show you next after private key where you can deploy this and how we get full set Cipolle tokens. I want to show you that you need your deployer, admin and minter roles. What does it mean? It means that our contract gonna have different roles. Deployer it's like usually similar with private key, but can be even different. Admin it's who gonna like blacklist users, unblacklist them, like to check all this stuff. And the minter it's the one who gonna mint tokens actually. You see you can do separate responsibility. It's usually in some hard tokens how they do this. In not just ERC20, not just scam pump.fun shit. It's how it's gonna work in a real application, protable. But usually even in a prot now in a crypto, they just do ERC20, OpenZeppelin contract token, and it's all. And it's even this, it's more good than just pump.fun. But okay. Next, Arbitrum cpoly, Arbitrum 1 RPC, you can state like this, it's already set up this, but you can change it to another networks if you want. Arbiscan APK, it's a PK if you want your contract has been verified, you can check it, you can take your Arbiscan APK on FRScan. Now they have version 2, so all your API keys for Arbiscan, Basescan, FRScan gonna be in FRScan, so you can take it from there, it's free. And the comma proxy, it's when we deploy our proxy, we can add it here, so then we can upgrade our contract with another script. How you can see, we have deploy and upgrade scripts, not only deploy, because we can upgrade the smart contract actually. Let's now go to smart contract. In SRC folder we have helpers, blacklistable, upgradable. It's like just helper to have a blacklist and upgradable accounts for there. Like you see, OpenZeppelin upgradable, we connected here in OpenZeppelin, and also we have blacklist storage. It's all these helpers that can help us to blacklist our accounts and upgrade this stuff. Also we have interfaces, common, but it's just that address can be 0, some like checker. So we not pay attention to this, I already prepared it for you. It's like usual development on Solidity. Next, we have our main goal, our comma.sol contract. Here we have imports for upgradable, and let me actually check how this ERC called, because I want you to know this. Okay, I found this in OpenZeppelin. It's ERC 1967, and how I remember, I say 57. Yeah, just like you see, it's not easy to remember all this stuff, but okay. It's just upgradable proxy that can give us a wrapper above our contract, above our ERC20 token. That's gonna like re-implement our contract and upgrade this, like update all of uninitialized implementation. You see, it's just some from OpenZeppelin contracts, some proxy that they created for this stuff. It means that you can upgrade your account, your code anytime, like change something of these functions or like some stuff here. Yeah, upgradable contracts is not always trustable. You see what's the problem, but usually in production people gonna use upgradable contracts because the corporation is growing, and when they want to stay in one architecture, they just upgrade contracts for a token to not like recreate a new token if they want to add something in future, and not mint it again. You see, it's can be a bit of a problem for some big companies. It's ERC 1967 proxy, I remember this, and it's just all about this upgradable. Upgradable, you see, UUPC. It's all this upgradable protocol that we need to use here. And next we have blacklist upgradable, but it's already like in our blacklist, and it's also gonna be upgraded because we have another, because we have helper for this. And we have our contract. I'm not gonna like explain you Solidity syntaxes, because you can check my another videos where it's like in not in advanced way, where it's just ERC20 tokens. I guess if you check upgradable tokens and like blacklist and role separation, it's mean you already can understand all this code, so I'm not gonna like review all of this. Yeah, minter role, we get roles here. Here you can change your actual token. You see, it's a simple ERC20 initialization like always, and here we like do this permit init, like, yeah, so we can control it in a upgradable way. Here we grant roles for our admin and mint role. In my case, I just do 2 separate roles, not 3. Deployer and admin is gonna be the same person for me, but it's like don't change this much. It's just for usability of this comma flow section. Next is some functions, like where you can mint this, and you see mint can only role for mint is minter role. I will show you it later in the frontend part. Let me actually show you interface of frontend for now. It's our frontend interface. Let's connect, but it's my backend is now turn it off, so we're not gonna see a token here, but we already gonna see. You see, if it's admin only, we can like burn tokens like an admin. You're gonna see this in our code next. And if you admin, only admin can blacklist and unblacklist addresses. If I will connect like a minter, I'm gonna have different interface. Let me even show you. Okay, it's my minter account recipient, and we now connected as minter. Let me check if it's correct. Yeah, it's this address. So we update, and as minter we're gonna see different approach. We're gonna see mint tokens, minter only. You see, we not see admin only stuff, only minter ones, and it's all goes from our smart contract. It's like already founded here. Burn, if we can burn if we have some allowance, if it's not zero amount, and like allowance is gonna be in this burn. If we burn from here, you see we can spend some allowance to burn, because if we're gonna have like not separated responsibility stuff, some guy can just go and burn all tokens, like, and burn. It's like burn project, not just tokens, like, you know, if he burn all tokens, he burn project. He like buried project by burn tokens. And here is pay attention, it's update function. It's like what's different with previous videos. It's update function, and Jesus, some devil like I don't know what's happened. Give a sec. This guy just tried to get me a heart stroke, but okay. It's just some, I tried this mask before and I forget about this, so let's continue. We have function update, and in update we have blacklisted, is blacklisted, and if account is blacklisted account, we like can't update with blacklisted account, but it's just like some ifs for like to not broke contract at all. And for super we can just do update. But you should understand that update can do only like deployer admin, like in my case deployer and admin it's one person, don't forget this. Function of trace upgrade, it's like default admin role, you see. Why I say that deployer for me can also do, because it's one person for me, I will repeat it again. But if you're gonna change deployer and admin roles, pay attention that only admin can redeploy this contract, like upgrade it. Not even redeploy, upgrade. Upgrade, it's a bit different from redeploy. Yeah, in its whole contract you see some simple decimals. Pay attention that it's 8 decimals, it's Bitcoin style. Yeah, I forget to say it in the beginning of the video. It's another difference between this is in just ERC20 account. And all other is just in our usual OpenZeppelin contract, ERC20. You will ask why we have comma v2.sol here. It's because I want to show you how to upgrade contract. But okay, let's first go next. Let's imagine we create contract. Now we can first build. You're not gonna have this broadcast cache and out folders at first. You're gonna get them only when you build this by first build. Let's actually check again. Yeah, it's built successfully, you see. Username on all this import. It's never mind, it's just some like plain import initialized, but for the build should be okay. Yeah, it's just some like warnings, but it's not even warnings, it's just like prioritized to like some formatter wise. But it's built okay. And now how you can test this, you can just use my forge test. I already write tests here. I'm not gonna like pay much attention to test. It's just some test to check it with balance, total supply, test mint blacklist transfer. Here you see we create some prank, and then we mean this prank in this way. It's not like some street prank. It's we simulate our minter and we check if it's real in mint result. So okay, I'm not gonna like check tests. You can check my another videos with tests, but I just think it's gonna be useful for you to have these tests here. And you see we did test and all tests passed successfully. It means our contract is fully workable. Let's go. Next, how you can deploy this? You can use my function for deployment in Arbitrum Cipolle. Yeah, if you want to deploy on another, don't forget to change it in env. In my case, we will deploy in Arbitrum Cipolle. I'm not gonna change my already connected contract, but I just want to show you how deploy work here. Deploy, pay attention, we use private key to deploy. It's return as proxy address, and this proxy address you need to use here, because this proxy address gonna be similar every time you're gonna upgrade. When you do upgrade, pay attention here, when you do upgrade, like 2, 3, 4, 5 upgrades, you still gonna have the same proxy. You don't need to change proxy, because this proxies handle all upgrades inside itself. Yeah, because the people think that if they do one upgrade, they need to change proxy again, because address is changed between proxies. But no, proxy is still the same. Yeah. Okay, it's deployed. You see, you can take your deployed address here. How I already say, it's Arbitrum Cipolle chain. How much we use gas. If we check in Arbitrum, in my another account, yeah, in the recipient you see I not have tokens now. I don't remember on what actually my deployer. Let me check. Yeah, okay, my deployer is dev. I just check private env, and in dev it should be, yeah, we're not gonna see it in activity, but it's already deployed. But just you see what's the difference here. It's deployed, but it's a proxy. Chain execution, it's actually submitting verification for comma, and it should be verified successfully. All contracts were verified. Yeah, you see, it's good. For us, let me take comma proxy address, and I want to show you now what I have when I deploy this contract. If you check my another video about comma achievements, comma SBT, it was with AI implementation, where you can create quizzes, and with AI I just create some token there. But when I deploy this contract, for some reason this addresses was the same. Check token contract address here, and this token contract address, you see, it's a Cipolle Arbiscan, and this just Arbiscan. I guess it's just some I don't see something here, because I think I don't know, I checked in search in code and I didn't see this Arbiscan contract there. I don't know how it can be possible, but it's the same address. Maybe it's a coincidence or no, but I don't believe in coincidence like this, because it's almost impossible. It's billions of possibilities there. Maybe someone knew and can understand why this happened. But yeah, it's strange. It's literally the same strings here. Yeah, you see. But okay, it's we can close this now. It's my account that I use for my actual deployment that we're gonna do, that we're gonna check in the future videos. But let's check your deploy that you actually deployed. You can check it by proxy here. Our contract is verified, but you see the contract is proxy. You will ask, what if why I just see proxy code? Where is my actual smart contract? I want to read contract, but it's proxy. I can't read. You can just click no. You can just click more options and ask here, is this proxy? Yeah, even this is possible. Verify. And yes, this is proxy. Implementation contract is found at this location. And we can go to actual our contract location, and it's our actual smart contract. You see, if you check it here, it's our comma that deployed again. It's deployed 4 minutes ago. It's deployed through proxy. This proxy gonna handle all your upgrades in the future. And now we're gonna go to upgrades. It's your actual contract, and proxy gonna handle all this stuff. RC 1967. So let's go next. Next, we deploy this. And that's a BI generation. We don't need it for now because I already have a BI generated. It's gonna be useful for our next sections, for subgraph, for frontend, etc. But yeah, you can generate a BI like this. And now upgradable UUPC. Deploy new implementation, collaborate to with proxy address remain the same, just some stuff to describe. But actually you can upgrade it like this. Just change to upgrade script. What the face have? Yeah, I didn't show you deploy script, but it's just some simple deploy script with env addresses like admin and meter. Don't forget to do like a source with the env. Actually, let me find this terminal code. Yeah, like this source env. Echo it's where you can check if this source env is correct. Like source env, we click on source env. And now if we check, for example, echo proxy, we're gonna get proxy. It means it's already in our source env and it's okay. So don't forget this, because people usually forget to add source env and they don't understand why their contract is not deployed. Next, to our upgradable. Now I want to show you deploy also. Not deploy, upgrade also. For upgrade it's even simpler here. It's just upgrade script that gonna have proxy that gonna handle all these upgrades. Yeah, I already show you it below. Yeah. Upgrade is script and we start broadcast. And we just do new implementation on v2. v2 in our case we just add function version there. In our original contract we don't have this version function. And when we add this function in v2 you can create v3, v4, like have some git style, separate contracts, so you can understand where you add, what you add and where. And here we do upgrade to and call. Don't forget that now it's upgrade to and call. In the previous version it was just upgrade to without and call. So if you're gonna try to use some GPT, it's gonna be broken. I can use my template and it's gonna be working okay. Now let's try to upgrade our contract. I actually need to change proxy. Give me a sec, I will find this proxy again. It should be in my buffer. I record this and for some reason recording is not work and always waste all the final part of code. So we stop on our upgrade contract, on our upgrade script. It's the last of what we need. You can then verify it, but it's gonna be verified automatically. We can cast upgrade, but in my case I need to upgrade it like this with some changes in upgradable. We're gonna add our actual proxy there. Yeah, our actual proxy gonna be added there. It's proxy, you remember we can get this proxy from our actual deploy. Yeah, it's the same proxy. And now we can upgrade. It's gonna work even like this, but in your case you just add it here and it's gonna work correct. I just don't want to change my real env. So contract is upgradable, you see it's fully compiled. Pay attention, we don't have return here with the new proxy. It means it's like just upgrade, not deploy function. Proxy is still the same. Verification is still pending. v2 in v2 we just add this new version function, remember this. And contract is verified, all okay, we upgrade our contract. Now if we try to verify our upgrade, we can just use this one. Let me change it to first. And if we verify it, we already can see that v-test2 is now verified, because it's mean like version call is proceed. It's mean our contract now have a function version also. Now let's check it in rbscan. Let's go to our proxy again. It's our proxy that you deployed with me. And yeah, it's first upgraded when I recorded it 5 minutes ago. It's why I'm a bit angry now. But now it's 58 seconds ago, it's the last deployment now. And it's mean we can try to check if it's proxy. And then when you verify it again, you're gonna get your last upgradable contract version, because proxy gonna check the last contract by time. And if you check now, it's comma v2, it's not just comma, and you see here it's comma v2 function version. It's mean we fully upgrade our contract. It's your first fully upgraded contract with UUPC 1967 proxy protocol. So it's mean we have our old functions, all our old functions and contracts, and we have our new function inside contract, and it's all gonna be handled by your proxy. Let's go. You see, it's not as hard as you think, this UUPC upgradable things, but yeah, in some way it can be discussed, like if it's like, because the blockchain itself shouldn't be upgradable by theory, but you see, for some people we need upgrades sometimes for some hard projects when it's like big tech corporations. Yeah, it's okay. So all what I want to show you, actually you can try to mint tokens, burn tokens from your terminal, from your Ubuntu terminal, but in my case we're gonna do it from frontend part. I already showed you before how it's gonna look on frontend part. So it's mean that now it's all with Solidity smart contract next. We're gonna speak about subgraph. We're gonna call this smart contract functions inside subgraph. Indexer it's in Arbitrum Cipolle, deploy all this stuff, and you're gonna see how it's gonna work with the subgraph. So with a smart contract it's all. I'm gonna see you in the next video about subgraph and about backend, I hope, and about frontend. Let's go. Hello, in this video we're gonna speak about subgraph and how you can use modern 2026 check date subgraph. You're gonna see full flow, how you can deploy it like on Arbitrum Cipolle or on production side and every other chain, and how you can actually create this subgraph at first. I have this repo, it's gonna be full open source, I guess. What's the reason for this repo? Tokens full stack Web3 architecture is gonna be repo where we already have video with the contracts. I guess I will create it first. Then subgraph video, what we're gonna do now, and then we're gonna connect the subgraph to our indexer and like REST API backend, and connect backend to backend and smart contracts. Actually, like imagine out of there. We will connect it to our frontend side. In this video, subgraph. So you can find it in a subgraph folder. Yeah, it's obvious, but still. In subgraph folder you can take fully my template and work with me. You can use this template for your own projects in the future. Now let's go to code, to our subgraph. Yeah, let's close backend. We already opened subgraph folder, and we see here some easy architecture. ABIs, it's ABI, it's mean our smart contract ABI. In my case, I'm not sure, maybe you need subgraph without like Solidity, so you don't even need these ABIs, but usually it's used as one. Usually subgraph it's like for Solidity and crypto stuff like this. You can find these APIs like just in my previous video. I showed how you can implement this ABI, application binary interface. You can take it from your smart contract or SRScan, for example, or just from Foundry. You can just do some function there. You see on terminal from previous video is open. You can actually, I have in README in my comma protocol. Let me show you. In README you just have this command that you can use for forge inspect sol comma ABI JSON comma, and you're gonna get your ABI in JSON way that we need already, and then just copy it there. So we now close our comma protocol. And next is our build. We're gonna build it with the command and generate it. It's two folders that we don't care about. They will generate automatically. We have this schema subgraph that we're gonna need. subgraph YAML that we're gonna also need. It's important. In package.json we just have graph protocol graph TS, like nothing else. And in SRC we have this common with some constants, some helpers, and mappings. Important part for map our graph, our subgraph, to show it in actual interface in a subgraph site. So let's go to readme file. You can use this readme file yourself. My project structure already showed to you. First, like imagine you copy this repo. First you need to do is install dependencies. Like you can first I recommend install globally graph CLI to use then commands like graph, authorization, etc. But if you don't want, you can skip this and you can just install it with yarn install, or you can install this npm install, or whatever you use for library like aggregator. Imagine that we install everything. Let me do this process with you, like I just create this subgraph. We open this folder, and in subgraph we do yarn install. It's done because it's one library, you see, 0.14 milliseconds. Next, build the subgraph. Imagine that we already have some code. I will first show you this code, but then we're gonna use this. Let's for now do like this. And now we're gonna speak about foundation. It's subgraph YAML and schema GraphQL. Subgraph YAML, it's your, in my case, smart contracts aggregator, where you can add all your smart contracts. In my case, it's only one smart contract, you see. It's only this source address, but if you need more, you can add more. Yeah. In my case, it's just this comma proxy from my previous video that we deploy. It's UUPS, it's mean ERC 1967 upgradable protocol, like upgradable smart contract with a proxy approach. You can check in a previous video how it works. In our case, we don't interested in this because it's gonna work in every way with all your contracts there. Now, important stuff, it's start block. Yeah, I write to myself to not forget this. Start block is block where actual smart contract is deployed. Let me show to you. For example, this is my proxy. You see, it's the same contract. And how you can understand from what block you should start. Actually, you can just check your first transaction hash. It's a better. And in first transaction hash, you can find this block where this transaction is happen. It means that contract gonna be indexed from this block. It's important because if you don't add this block, if you stay with my block or something, you're gonna wait indexation longer. It's gonna indexate events that not happen because your contract was not created when these events happen. Yeah. Like, I mean, your contract is created long above the start blocks. For example, a current block, I even don't know. Let's check, 27 hours ago, it's already, you see, a bit of a bigger block, and it's all take time to index. So you can check it in your deployed contract, start this block, change this parameter. And next we have this template. For us, we only need to take in address, in ABI that we're gonna use. In my case, it's this comma ABI. You can change naming if you want. And network. I stay comment for Arbitrum1. It's like production ready network for subgraph. But in our case, we're gonna use Sepolia to not waste real tokens. You can check in my previous video how you can get Sepolia faucet. Start block. Okay, I will say about this. And here you need to add all your entities from smart contract and all your ABI's handlers. In my case, it's like these ones. I recommend you to use some GPT with this, like just add your ABI to GPT and ask to show all stuff that you have. So it's gonna create it for you, because it can be a bit annoying, or you can use some templates. Next, subgraph, it's okay, you just in subgraph YAML you add all your smart contracts with handlers. Next, schema GraphQL is important part. Schema GraphQL, it's where we're gonna actually call what we can call, and all these types we can call in our subgraph when it's gonna be deployed. My subgraph already deployed, so I can show it to you. For example, mint there. You see it's when we mint token. In my case, it's I already said to you it's token. So we have this mint with the mount time step when it was minted. Mint, it's like create new tokens for this. And if we go to subgraph, it's my the graph. You see, it's not studio, it's just the graph. It's like studio for testing. It's not production published version. It's studio like for playground. And here we have mint and burns. You can create your templates. In my case, I just in dashboard have this dashboard. And here you can check actually your graph authentication. If I show my authentication, I will cut this. Okay, I will just hide this with some stuff, so no worries. Pay attention, we have selected Arbitrum Sepolia network. If you want to use another network, you need to choose another network. And it's actually what I have in my code, graph init, flow, but my template already have this initialization. You just need to change namings and stuff like this. Authentication, but authentication gonna be fully on terminal side. And then some commands here, instructions. In our case, I want to show you this playground, and in playground we have our explorer there. I already show you mint in my code. Pay attention, in mint we have ID, to amount, timestamp, block number, transaction, lock, index, and minter. And we have all this stuff here in mints. Yeah, maybe it's surprise for you, but yeah, you see it's the same. It's what we're gonna deploy actually, all this. You're gonna ask me why we have more than we see in schema. We not have more, it's just a subgraph. It's divided by mint in a single instance and mints in a like a first 10 or order by order direction. You see, you can call it like array or just like single instance, single object. So let's try to call this, and we get all these mints that we already have. It's my mints that I already did for my for my comma flow. Yeah, I will show it later how it's gonna work in a front-end side, not in this video. And if we check just mint, you see we can get some mint ID. For example, we can try to copy this mint by ID, and I'm not sure that it's gonna be fully correct. Let's check. Yeah, we get this only this mint. It's if you need some single mint, but usually people use array of objects here, like not on mint, but just first 10 or first 100 even. But pay attention, you need to be careful with this, because you have limits like 3600 requests per day or something, so pay attention on this. Next, I show you schema GraphQL, so all this stuff, it's what we need to add. In my case, it's this mint, burn, transfer, it's all from smart contract from ABI. You also can ask GPT to create all this from ABI stuff. But what I want to show you, it's actually constants. In the constants, pay attention, we have 8 decimals. It means it's BTC like comma token like BTC. It means it's have a lot of amounts. And contract address like inflation. And contract address, it's our proxy address. You can change it. You can check in previous video how you can create your proxy address with a Solidity contract. And roles, it's also a theme for previous video. You can just take it from there. In a brief, it's just we have minter role, and only minter can mint tokens. But in our case, it's okay. And default admin role. In helpers, we just have 2 decimals as generate ID helpers. we intersect in our mappings. In our mappings we already have some stuff from generated, you see. It's mean that we need to actually do code gen. Let's go. Yarn code gen, it's when you already have schema and subgraph YAML. When you do code gen, you're gonna get all this stuff. If I delete built and generated, it's gonna be created again. Like in generated, in yarn code gen, it's gonna be generated, created. Yeah. And in build, I guess, you already understand it's gonna be build created. So you see, for us, yarn code gen, it's okay. All skip migration, it's good in my case. Load contracts ABI, our ABI is fetched. Generate types for GraphQL, and generated, now fully generated. You see, they now have their generated file where they're gonna use it for mapping. Now we can actually stay with build, and for mapping you now can connect your mint2 event params. It's just like some template for generated. You call these methods from comma.ts. You actually also can ask GPT. Yeah, you see, usually in subgraph you just ask GPT to generate from your ABIs, because it's annoying to do manually. Imagine write all this manually, like just all this count timestamp number transaction, like blacklist, mint somewhere there. It's what we check. Yeah, mint, you see, it's the same parameters that we already see, but you need to write them all again. So I recommend to use some code generator to be fast in this. So my mapping, it's all what we need to know about mapping. Just take my template and change to yours. No, I don't want this. And change to yours. I don't want to insert. Jeez. Just change to yours, and now let's finally do build when we have all these mappings, etc. After build, we're gonna get this build folder, and when we have build folder, it means we can actually deploy. You see, I can delete this and it's gonna be generated again, but I think you believe me that it's gonna be generated okay. For authentication, I add this stuff for you here for deploy subgraph studio. Graph authorization, in your case you need to deploy with your key. What does it mean? It means that you need to go to API key section in your graph and take your API key here, like copy key, and just pass this key in graph authorization. It's one-time process, so I'm not gonna show it to you. It's just like to have it in a CLI. You can use different approach, of course, but it's gonna be the fastest if you're gonna use subgraph often. And now we can deploy our yarn. In my case, deploy process gonna be just like check this. We have versions. We have 002, 001 deployed, and I need to wait indexation again if I create new one. Pay attention that for now blocks behind is 500. Current block is this, final block is this. If we're gonna do redeploy without change of schema, I think it's gonna be okay for indexation. Let's actually check this. Yeah, in my case I just do already updating, but in your case you're gonna do first deploy. It's like not a big difference. I'm just show you this in this way. In first deploy you're gonna see the same thing, so no worries. And now version 0.03 video, and now we already deploy our not smart contract, sorry, it's from previous video, our subgraph for this smart contract. Build complete. Okay, build done. Deploy done. Query here, you can find it by this link. Let's try to open this. Yeah, it's just fully strict. It's just fully strict link. In our case, you can just go to your studio subgraph, and you're gonna find in my dashboard your deployed contract. In my case, you see I did update, so in my case I already have. In your case, you're just gonna see this new contract, you're gonna click here, and if you're gonna update, you're gonna see this new version. Yeah, you see, in my case, 003 version is deployed, and by indexing, it's okay, it's the same blocks, because I didn't change schema. But pay attention, if you're gonna change schema a lot, you're gonna need to wait indexation again. What does it mean? You're gonna ask me, why is this synchronization, indexation? In crypto, blocks go one by another, like, I think you know why it's called blockchain. And Subgraph, what Subgraph did is just like try to fetch blocks from your block that you get here in start block. Now let's go here in the first start block, and from this block Subgraph start indexation. He check every event that happened from this block. He extracts this event from a contract. Yeah, because we have these events in these transactions here. Subgraph just extract this once, and with Subgraph you can easily like check this for your admin dashboards or some another stuff. And like you see, for me means they happen in different time, but I have all these means aggregated there. So it's how you can use Subgraph here in the means. Also we can check our upgrades, it's gonna work correct. For example, let's close means and burns, and for upgrades we're gonna get first 10 with block numbers. Let's get all these parameters. And I have one upgrade, yeah, and we see exactly one upgrade. It was a long time ago by timestamp. Timestamp and just like you can check timestamp actually. Let me show you. By epoch converter, you can get it by this. It was 4 days ago when I created it for myself. Yeah, you see it was December 31. It was previous year. Yeah. And it's my first deploy of this year. It's already my frontend part that's gonna be in the next videos, so you're gonna check them too. But okay, you can save these upgrades also here. Upgrades, like for big subgraphs, it's gonna be useful. And even if you close this, you can then just go to this upgrades, but I can't go on upgrades now because I'm already choose upgrades. But if I do this blacklist, yeah, you see I only have upgrades. Oh no, I think I'm not save upgrades. Yeah, I actually save them, but yeah, I need create one more for this. Yeah, let me actually try with meta. Meta, it's our deploy. Save. I resave this. Meta, and now upgrades, save as new. And we're gonna switch between them, and you see we can get our patterns like this. So in my case, it's all looks good. For you, you're gonna see indexing not 99%. At first you need to wait some time to actually get, if you're gonna see empty means or something, even if you have some means already or some another stuff, some events happened, you need to check if block when it's happened it's past the current block. If it's like this, it means it's some problem in your subgraph. If current block is not when this event happen, it means you need to wait for this event. And next, let's talk about publishing this subgraph. In 2026, in modern subgraphs and the graph, how you can actually publish, you need to just click button publish. I'm just joking, you need a bit more. When you click publish, you're gonna get this indexing from Arbitrum Sepolia, because in subgraph YAML we declared Arbitrum Sepolia. It's mean in our case we have this Arbitrum Sepolia here. For Arbitrum 1 you need to comment this and uncomment this one. But in our case we have Arbitrum Sepolia. I have another repo that already deployed, I will show it to you. But just want to show you this without actually deploy this one, actually publish this one. the first two signals, the subgraph you see, and people gonna see this here, like be the first to see signal. Like what if I signals? What does it mean? How I just can publish to prot my subgraph? This signal, it's mean you can take some signals for people who like have these signals. I forget how they call by documentation actually, but these guys, they staking these GRT tokens and they can like deploy and maintain your subgraph, your graph and subgraphs in their system, in their nodes, how I understand. But you need to pay some signals for this, you see. You pay the signals and the signals gonna stake in them, but you're not gonna lose all these signals at once, so no worries. Even when you do signal, you can actually cancel this. In my case, I don't have signals because I already waste all of them in another, but I will show it to you. Yeah, you see, the graphs it's fully zero because I use all graphs to find some indexer guy. And let me show you my another account. I can't even publish here on Arbitrum Cipollio. I'm also, and it's don't have sense to publish on Arbitrum Cipollio because you're not gonna use Arbitrum Cipollio as your production site, so we're not gonna even concentrate on this. Let's go to my another repo, and if you check, this repo is published. You see, this repo is already published, and it's mean that this fully synchronized, you see, published by this, and we can go to subgraph on Explorer, because Explorer it's our actual Explorer, it's our actual production site. That's gonna be, if you go by this, you're gonna see it too. So it's production site thing, and we have some indexing here, you see, some guy indexing this. I get 562 signals, it's mean 562 GRT tokens. And this guy takes these tokens, it's like $20, so no worries, it's not really, it's cheap. So this guy is fully indexing this when you do this query. Query. First you're gonna see the signal, and in signal you can get your share. For signal you can unsignal this, but this guy actually I think he then not gonna indexing your subgraph anymore if you unsign this. So you see, this guy tried to stake in it to get some money, but from $20 I don't think that he gonna stake much, but I think maybe it's just some bots there. So first you need to have signals, you need to get some GRT tokens. You can get these tokens by just like swap them, like for example swap them like this in a MetaMask or whatever you want. Here for example 74,000 GRT tokens for one Ethereum, but okay, in my case I don't need this. It's a production site. All what you need to know about production, you just signal and you wait for some guy to index this, nothing more. And in production it's gonna work also like this. So you see, it's gonna work, and now you can use it in your backend, in your production ready backend, and in your other projects. Like it's now accessible for every people, not only on our local playground. This one is only our local playground. So it's all what I want to show you about subgraphs. If you have some questions, ask me. And in next video we're going to backend part. All subgraph you can find in open source description and can use it for yourself. For now, let's go. Hello everyone. In this video we're gonna continue our cycle of CommaFlow. I will remind you that we already checked Solidity contracts, we created and deployed our UVPC contract with proxy. We created subgraph that we can call. You can check in the video, we're gonna use this subgraph from CommaFlow. We're gonna call this, and in this video we're gonna speak about our backend indexer and REST API. We're gonna create this backend. I will show you this in a template, and you can find this template in description. Now we're on a backend folder. So you see all here is aggregated at once. Now I already have frontend, but for you you don't gonna have frontend, but at least you're gonna see how frontend's gonna be alive. You see, for now, if we check our network for fetch XSR filter, we're gonna see that all requests failed. Yeah, we already have some requests, it's some spoiler, but they not work. And frontend is just give us mock data and some placeholders. But we're gonna create backend and gonna turn it on, and we're gonna see that frontend is actually gonna fetch backend data, and we're gonna create frontend in the next video. But for now, let's focus on backend side. We in our backend folder now, in common flow repository. You can take it yourself. It's will be full open source code, and you can check all instructions in readme, but let's check it together for now for this video. Yeah, you can read some features here. If brief, we're gonna have real-time indexer from Subgraph to store it on database. Complete analytics, like we're gonna fully track our smart contract. Historical data to aggregate this for charts. System monitoring, but it's like not important for us. And REST API. Yeah. What we're gonna use Node, PostgreSQL versions. It's not like requirements here, it's just not older than this, cause it's classic ones. If we check our package.json file, you're gonna see that we use Prisma, Axios, GraphQL request to get these queries, PostgreSQL, and other stuff like this. So from our main technologies, how you understand, we're gonna use Prisma to actually create these schemas. Then GraphQL and actually our Postgres database. All other is like standard. You can check my other videos where I created more complex stuff for backend, like AI implementation with, let's say, backend quizzes with a lot of tables at once. But for now, let's check. Imagine you just install this library. Like you download a repository or a git clone or something, and first what you need to do is like do some installations of all this stuff from package.json and npm install. Don't forget to change directory, because I didn't change it for now. Yeah, oh, I see. Maybe here it's backend. No, it's subgraph everywhere. Let's change to backend. Change directory, backend. Now we on backend directory. We can install all this again. Let me do this again with you. npm install. And while we wait for installing, well, it's already installed. We don't need to even wait a lot. Don't forget to add your env, real env, not example that I have. In my real env, it's a bit of private data, but if you check example, actually from private data, it's only a graph API key. You can check where you can find this API key. Actually, let me show you. This API key you can find in API keys there in your subgraph from previous video. I already showed in previous video how you can find this. Yeah, you can take your API key from here. It should be the same key as your deploy key. Yeah, like not deploy key, but I mean just the same as your subgraph studio, because it can be a bit confusing. Next, we have here database URL. It's our database URL. Let's just step aside. No, we're gonna speak about this later. We have subgraph URL where you need to add your subgraph that I already showed to you. Just link, you're gonna have this link in subgraph. If you check it in details, I guess you're gonna see this link somewhere here. Where is this link? No, it's actually not in details. Yeah, it's in endpoints, sorry, not details. And in endpoints you can find this link for 003. And it's gonna be okay, you can even check some template there. Next, Subgraph URL, it's when you're gonna be in production site you're gonna use another URL, but for now we're gonna use local backend port. That's port where backend gonna start. It's gonna be useful for our frontend to locally connect this. Index here full interval and snapshot interval, it's intervals when index gonna be happen, like when subgraph calls gonna be called again, because subgraph have some limited restrictions also in the calls. For your local environment it's 3600, how I remember, calls per day. And snapshot, it's like when it's gonna be saved in database. Next, Graph API key. It's already speak about this video. Comma contract address is contract address from where we deploy this. You can check previous video about smart contract where we deploy it. It's two themes that we need for we can take from smart contract video site. So okay, let's go. Next, in readme we set up our environment, because people usually forget this, and database setup. For me, I'm just gonna use pgadmin, because we don't have some hard tables, and I propose to you just create your new database here. It's like you just can click here, create new database, call it somehow, in my case it's CommaFlow, and connect the database. Yeah, I don't need to create another one. I already have this database. You see, CommaFlow, it's fully operable. And we have some tables already here, but you're not gonna have tables at first. We're gonna need Prisma to generate these tables first, and to have some seed in there. Important note, pay attention on the PostgreSQL where you use this. For example, for me it's port 5433, but for you it's usually 5432. It's default port, but for me it's a bit not default, so pay attention that in my env we have this different port, and if you're gonna copy my env example, it can be a bit confusing at first, but you need to just check what port is yours in the PostgreSQL there. So next, we create database. You can create it also with this PSQL CLI, but for us we create it with pgadmin. It's even faster. And next, update env, yeah, update it like I already say, and we are already doing pm install, so we can actually run our Prisma migrations and seed data. First, you're not gonna have this migrations folder there. Before you do this, you need to run Prisma generate with your npx or whatever you use as a script launcher or as terminal. And first they're gonna generate our Prisma scripts that we have in a schema Prisma. Let's talk about schema Prisma, because you see we have some generated client there, and schema Prisma is just our schema of all our tables, how they're gonna look and what table rows and columns they're gonna have. If you check my previous video, I think you noticed that this almost similar with our schema GraphQL. Yeah, let's do some comparison. We have, for example, mint, and we have mint event there. We have all this stuff. You see, it's similar. Yeah. Yeah, it's obvious that it's similar, but here we have some another stuff. But you just need to add your schema GraphQL in my case, or some tables that you need to then fulfill, that you're gonna use in your backend site. But in my case it's gonna be same as subgraph schema, because it's logically correct. But we're gonna have some difference there. We're gonna have only unique transaction hash and log index, so it can be the same transaction hash and log index, because it means some event is broken if it's gonna save twice one transaction, because transaction hash is always unique. We can index block timestamp and to address, like it's how we can find this stuff in our index, like how we're gonna actually find this, but usually it's checked by time. It's just Unix epoch time and timestamp. You're gonna see it later. Next we do generate, we have our Prisma schema, you already gonna have this from my template. Actually pay attention on config, it's just PostgreSQL, it's new code there. Here you see it does not exist in type, but it's gonna work okay, because it's their last version, so no worries, it's gonna be fully good. Next we have seed there, we gonna need the seed soon, but first let's do migration. I think you all knew what mean migration in database implementation. It's mean we just create our database tables, or we add some new rows or columns in our tables. In your case, when you first create this, you just do migration, and you're gonna see these tables. And pay attention for whenever you update schema, Prisma schema or some updates, you need to do migrations again, because you add something new in table, and you need to add this in a table also here. For example, if we do migrations with our schema, we have mint. Let's check mint events now. And if we check mint events there, it's like just some PSQL queries, but for us we just do it with interface. And if you gonna check here, we have this index, transaction hash, log index, block number. It's all from our schema Prisma actually. If you check, it's similar. So we just all from Prisma, and for migration we generate this Prisma. You're gonna have empty table for now. I'm already have some mints there, because I already did another videos and I did testing in Frontend side. So for you it's gonna be empty, but if you see a table here, it means it's already okay. Like just empty table with this with all this text from our schema. Give me a sec, I need a bit of water. Let's go. We talk about PostgreSQL admin database panel. Like it's easy implementation here. Next we need to seed our database to have some values here, so it's not going to be fully broken. For example, some system alerts there. And okay, let's actually copy this and do the database seed, and let's check seed TS. If you check in my script, by seed we just call this seed. Yeah, seed command has been executed successfully, and in seed we just have this table result. You see we starting database initialization. We check if tables exist. If tables not found, we need migrations, but we already did this before. And if tables exist, we can add some existing alert, like system initialized and stuff like this. This seed is just example one, you see, but you can add some mock data here if you want to test it in frontend first without even some means from smart contract side. Like you need some database, but you want to type it manually here. Yeah, you can change it manually in every of this cell. But if you don't want this, you can use this migration seed, like seed script for actual testing. But you need to write something more than I have. It's just template for you to use this mechanic like in games, you know. And next we need to configure our subgraph. I already speak about this. You just need to change subgraph to your deployed one. It's theme of a previous video. And we can start server, but before we start server, let's say do fast review of our code. I'm not going to explain everything because it's simple TypeScript implementation code, and you can actually read all this stuff here. What I want to show you here, testing is we not in testing, database inspection we gonna check it from pgadmin, so it's just some examples for you. Yeah, I think it's all. You can read this, just some stuff that can be useful for you, but I will show it to you in the practice. We have this src with index. Usually we start with index. In index we have health endpoint, but it's just like default endpoint. And then by rows we just have API with dashboard rows. You can add more rows there, but for us we only gonna have dashboard rows. we create server, and here is some fallbacks to start indexer service and like to quit gracefully, you know, because I think you solve this sixth term not once in your career, but still we need to have some fallbacks. Usually people forget about this. Yeah, you see we have dashboard rows, we can open them, and by dashboard rows we're gonna have token overview, mints, burns, transfers, blacklists. Actually this all is just the same subgraph that we have here. It's gonna be same schema there. For example, if we check not upgrades but mints there, mints by first, let's check some mints there. And we call mints, we're gonna get this data, and we just need to transfer this data to backend through indexer. So you see, in our case, Subgraph already did all this job with understanding what we need. I'm not gonna like show everything, but pay attention, it's all in our dashboard controller, because you see it's not a small component here. Frontend is even bigger. So let's just review it on mint, so you can understand it properly. We have get mint history, we have some limit how much we can call, so it's not gonna be broken on backend side. We have this mints from Prisma mint event find many, and you see by Prisma we just check events from our database, from our PostgreSQL, and take some events almost similar with the subgraph, but it's not subgraph, it's like yeah, it's really looks like this, but it's just Prisma works in this way. We just show what we need to call here, and we call this transaction, this mint transactions in our get mint history. Next we can like call total, how much we have mints. It's gonna be useful for our admin dashboard in the frontend part. Like we can show how much mints even happen. You see, it's all just functions inside Prisma, inside mint event. And we have this response that gonna actually handle all this data and pagination, and it's all that we gonna have in our caller side, but it's not all. Follow requests is the same, but it's not all that we're gonna have our indexer. Like this is REST API logic. Imagine that controllers, it's our REST API. Lib, it's our Prisma, but it's you don't need to touch this. I'm already set up all this properly, so you don't need to change here anything. If you only don't need to change some max attempts or stuff like this, because usually people forget that Prisma is get updates also, and you need to have new pull implementation now from your PostgreSQL, from adapter BG, and from Prisma client. You see, this implementation is modern 2026, and it's gonna work correctly. Let's go. Next, I imagine it's our REST API. It's easy, but I think interesting stuff for us here, it's not utils. Utils I just want to show you, it's utils with some formatting. Interesting part for us here is our indexer. I've already saw in our server list, and we start our index services. But what is this index services is some big component. Indexer manager, we don't even need this indexer manager here. Yeah, it's from my old code, so don't pay attention on index manager. I deleted it for now. For you have only indexer service, and you're gonna start it from here. Indexer manager, it's just manager if you want to unite many indexers, not only dashboard one. Like for example, we can have not only this ERC20 token contract, in our case proxy. We can have actually more contracts like minter contracts, some blacklist stuff contracts, and another stuff like this, vaults, blah blah blah. So you need indexer for every of this to be architecturally correct. Yeah, and if you check indexer service, we start this index service, and what's happened here? We have subgraph, indexer pool, and snapshot interval. I already explained to you in env. And now we have these queries. I think you understand what this means. It just means these queries from subgraph again. We write same queries that we have in our subgraph, and we're gonna call this like this for our indexer first. and only then we can call it from our actual REST API in dashboard controller from our database. In an indexer service is happen subgraph call and saving in our database. Yeah, you see some difference here. Indexer service, when we started, like you can check all this start logic here. We have latest block from the database. Like I'm not gonna explain all the stuff because it takes a lot of time. You can ask me in a private message or something if you have some difficulties in this. But it all should work correct. I understand that you maybe for your project you need to change some stuff, but usually it's just templates. For this you see process mint, you can just change on your queries, on your templates, and all gonna be good on your data. So this template is gonna be fully correct for everything. For example, process means that we already did example in there. You see for this means we fetch event means with means query. Query means this mean that I showed you. We do here fetch to our subgraph. We do this fetch that I already did this. Like imagine that it just happened encapsulated. And we check all these events happens, all these objects with means. And if they not exist, we create some. Like what does it mean? It means like if we find something but we don't have them, we add them to database. So if we have, we create this mint event in Prism and we add some stuff in database. Otherwise we just update last block and we get new mints there when index happen again. If we check it at least a bit bottom, we're gonna have fetch events here. You're gonna have these fetch events. How you can see, these fetch events happen everywhere in all this means. This fetch events is just our handler for events from subgraph. So this event is fetched from our last processed block. Every time we have this indexing here, it's previous video I'm sorry. And yeah, we have this batch size here, it's 100 batch size, it's like how much you can handle. Next we have this request, blah blah blah. Imagine it's just handled for our subgraph to call this and have some restrictions. Update last block, it's okay. We just update an index here last block that we have in our actual subgraph, because blocks is always updated every couple of seconds, even in Arbitrum Cipolle. Next we have take snapshot. Snapshot is when you do some check of your current events and save it to database. Yeah, you see, you calculate these totals, you aggregate all these events. You have total supply, token snapshot, and for snapshot you have total supply, total mean, the total burned, and imagine this snapshot is just gonna handle total data. And if you check in our NV example, snapshot is happen not as much as indexer pull interval, because the events can happen faster, like every 80 seconds. And snapshot, we don't need to do this every time, but snapshot is gonna also save our count of these events. So it's all indexer, all what we're gonna see in indexer side. And now let's check it on practice. Let's start our server. And when you do all setup, you can just start it like this. First it's gonna have an indexer here for you. Yeah, if you check, we just execute NV file, we save our NV and we execute index.ts, and how you remember in index.ts we activate the index servicer with dashboard rows also. Okay, and if you see, we running server, GraphQL endpoint, it's my GraphQL endpoint, you're gonna have your own. Starting from block, it's our block that it started indexing from. Yeah, you see it's like almost correct, it just have some a bit old data because it's starting block. And if you check here, it's current block already, this number already 8, but if you check started block, it's 2. It's block from where this history started. If you check this here, we can see that in started block we have the last processed block. So yeah, it's a bit strange. Yeah, I got it. Like persist block. Etymology of this word. I'm not native English, so sometimes I'm a bit stupid. It's last block where some event happen. It's mean last persistent block is this. If no new events not happen, we don't need to indexation and like snapshots again. We try to polling for new events. Event polling completed, indexer started successfully, and we see they do polling for new events every 80 seconds. So it's all work correctly. We polling for new events, and we actually start our dashboard routes also, not only polling events. I actually want to do some mint. No, I will do this on frontend when we're gonna do full flow and on full guide of this. But for now, let's check that our frontend is working. It's just for you to check new video about frontend, how this backend is gonna work actually. Let's update this. You remember that we have not working implementation of this, and now our implementation of backend is working. We get this as local host 4000, and we have some preview here for every of this that we already have on our dashboard routes. We see for now, for example, time frame of full overview. It's like overview that we created for this token. We created it for frontend implementation. Total supply of 4, because we have 4 mints, and this means by 1 or 2 amounts. If you check in subgraph, yeah, you see amount is 1000. Yeah, you see we have 2 tokens. How you remember from first video, we have 8 decimals in this token, so amount is only 8 zeros. Pay attention. For like it's actually 2 comma tokens, it's 1 comma token, it's 1 comma token, and it's just some 0 1. And how you see in implementation, it's really 0 1. That's last one. We have 2 1 1 and plus 0 1. So total supply is okay, it's fully correct from our mint, from our smart contract. We don't have burns, it's correct also. If we check burns from here, we're not gonna have burns at all. Like amount, ID, log index, we don't have burns, so it's correct also. It's not connected. Yeah, okay, it's just sometimes this your own wallet it's disconnect you when you AFK. Next we have 24-hour activity. We not have activity 24-hour, yeah, because it's tested. We have 2 holders and it's correct because I mint on 2 accounts. And net issuance is 4, like circulation supply. We mint 4 tokens, and it's mean it's 4 tokens in circulation supply now. We have this chart on frontend side. We're gonna speak about this on frontend side. What the fuck? Why my code is always like... my connection is always missing. I will check it on frontend part of my code. For now we're not interested in this frontend implementation. And we have this mint events here, you see. I think I knew why this happened. It's because my reown is now connected with 2 accounts. Yeah, and it's always try to switch. Because if I gonna have 1 account, it's gonna be correct. But okay. In event history we have these mint events. And transfer is the same as mint, so we just imagine this transfer is some test value. You usually don't need these transfers in a real production side. We have these transactions. We can check these transactions, but link goes to just rbscan, and we have Cipolla. I will fix it on frontend side. And yeah, for us interesting part is that backend is working correctly. All mints is here, all our mints with all our values, and it's all good, it's all correct. Only I'm a bit confused with this minter numbers, a bit wrong, but we don't care about this much because we have transaction anyway. You see, they just like in another coding or something. But okay, in our case we don't even need this for now, because you see you need to have address in good ways. But it's all I will check, it's all behind the video. So I think it's all for backend side. Actually, let me check this. I'm really interested what happened there. Okay, I did some fast fix, but at least it's okay now. It's not a good fix, but it's just some You see just some replace with formatting. Problem was with buffer, how always it was not correctly decoding from buffer. So I just change schema to string, so to get our string without bytes, and replace all these slashes that we gonna get from our escape JSON to correct implementation. So we're not gonna have these buckles. We will stay like this for now, but in the future we can do proper fix. But for you I will stay with this one for now, because we don't have time for all this on local network. So yeah, now it's for collector, we can see all our addresses and a transaction, and we good on backend side. I'm gonna see you on frontend one. Let's go. Hello everyone. In this video we're gonna speak about frontend part of our comma flow. We already speak about Solidity contracts, but maybe you skip this. You can find these videos, but it's like fully separate videos by itself, so you can check only one of this, what you're interested in. But we check subgraph, backend, and now it's our final part, frontend part. You can find all this code in description. It's gonna be fully open source project. And let me first show you frontend. Let me start backend first. And start frontend. It's not started, yeah. Yeah, frontend is not started. npm run dev for start frontend, because we're gonna use frontend on React, Vite, and Axios, like all this Tailwind stuff, like, you know, default for 2025, 2026, I guess, also frontend development, or in Web3 at least. But yeah, we start the server. Don't pay attention that I have this API, not just localhost 5173. It's because I'm use some external stuff, you know. But it's just my country, some specific of country. So we start our frontend, and what we can see first. Let's imagine that we not connected at first. We not connected. Disconnect. We can connect first. Connect our wallet. No, we don't need connect this one. Let me change wallet first. Fuck, give me a sec. Yeah, just change to Arbitrum Cipolle, so you're not gonna waste time while you're waiting. Because this frontend, this like backend, smart contracts, and subgraphs, it's all on Arbitrum Cipolle. So for us, we have this connect wallet. You can connect your wallet. Let's connect our wallet. It's gonna be recipient, and we connect it. And first that we see it's Minter. It's about backend video. You can check, and smart contract video. It's all there. Here we focus on frontend part. We have these sections with a token that I explained in previous videos. And how you can do this connection. Actually, frontend is gonna be the briefest part, because like I don't see a reason to discuss frontend much. I just want to show you how you can connect this backend to frontend. Actually, I already like did a full review, but from interesting part for us, it's like we can get all this transaction from backend. We can get all this like overview charts. I'm not gonna speak about chart, because like charts, it's not advanced time, it's easy. But pay attention that we have Minter only tokens, yeah, you see, and we connect it with this account, and it's Minter. If we change our account, that actually we're not gonna disconnect, we're just gonna change from MetaMask. Let's change it to dev. Connect from MetaMask, switch to dev. Oh no, it was switched automatically. I need to switch to 431. Yeah, and we switch to dev. And pay attention that dev is not Minter, it's admin and deployer role. So you see in interface it's also segregated like in different roles. You can check in the smart contracts in the previous videos what these roles mean and how you can create it on smart contract side. Here we just fetch these roles on frontend side and do it like this. So from interesting part, here is we have admin roles. like admin roles, it's you see it's fully different. We can burn tokens, we can blacklist addresses on blacklist, and it's only admin, and minter can mint tokens, of course. So yeah, let's go to code. I only want to show you the most interesting connection part, because I don't see a reason to review interface. It's like advanced level. I mean this, not interface, because interface it's like not interesting level for us if you already check this flow. If we check this package.json, also I already said that we have Vite, React, Tailwind, but we use reown appkit. It's how we're gonna connect this. I did it a lot of times in my previous videos. We're gonna use Efforts 6 version. And from interesting, some hook form, but it's like I'm not gonna also explain this hook form. So how we connect this? We connect this query client. Query client, it's stack client that we need to wrap our frontend, so we can do like wallet provider and other stuff to query this. It's only for this project, so no worries. With your own project, it's a project ID that you need to add from your Vite project ID account. If you check here, I don't have some private case here. I have my own project ID, but I don't care about this. Like usually people don't use this statistics there, so it's just my test ID. So I can show you everything here. We have Vite bus API URL. Actually, I need to create in the example with this. Give me a sec. Let's create it with you in the example, so you can just copy this. And let's just we gonna do this with your own project ID, and it's okay. Now you're gonna see this in actually my open source and can use it yourself. It's production URL, so you can do production site, but we're not gonna speak about this now. If you want, you can write me and I will help you with production with this. But like it's a bit different, because you need to have server, etc. But okay, we have this query. From interesting part for us, we have create appkit, and we connect Arbitrum and Arbitrum Cipolla, like reown implementation, like we always do. We have this localhost URL. For us it's this port, but I use a bit different one, but it's still not a problem for appkit. We have wallet provider. It's just wallet context that we're gonna use. We have some hooks with use token data. In wallet context, we're gonna use this constants from wallet. Here we have all our roles. Pay attention that you need to add your roles here from previous video, because your roles not gonna be my accounts, of course. My accounts can be possible on your contract. And here is like Kisak for these roles, but it's just classic stuff. And chain config for Arbitrum and Cipolla. It's for like chain config, we're not gonna use this for now, but I just state like template. For chain config we already have this in our networks, so no worries about this. Next, RPC. We can add it again, or we can just take it from any example, but I don't care much. And here is just we have update roles. If they changed between wallets, we gonna update full our interface. Yeah, I already showed to you how it's work. We have connect, disconnect, and initialize wallet, like all the context that we need to use for our connection, disconnection, and change of wallets between itself. So wallet gonna see when you change wallet, and it's gonna change interface, re-render everything. Next we have hook with use token data, and we have app, of course, where our application components is. Now I'm not gonna like show you all these components, because I don't see a reason to show everything. I just show some example. Yeah, we need ABI also, don't forget this, it's from another video. Not gonna concentrate on this now, because I'm already speak about it twice. So for us, we gonna concentrate on some example how you can connect this. We have this token API. In my case, it's like get overview, get mint history, get burn history. Let's like concentrate on get mint history, because we already have 4 mints in my smart contract. Yeah, so format comma amount. Pay attention, we have 8 decimals in my account, in my token, so we need to do it like in 8 decimals, not like default stuff with ERC20. It's more like BTC style. But for us, we interesting in get mint history, and we go to get mint history. We gonna go to our hook that I opened already with use mint history, and here we gonna do some query case for token and mints, and this query case is just go from React query, and it means that we query these tokens and mints. Let me show you it in our fetch. Mints. Mints, it's here. And if we check this mints, it's just some limits, 100, offset 0. It's all payload that we have for now, and we have some response with preview, has more, offset, total, and some mints that we already review on backend side. So for use mint history, it's all like you're gonna just take it from token API, this client with params, with time frame, if you need this. It's for usually chart or something. But yeah, I already implement this for your template. Get mint history with limit offset. I already show you that for limit it's 100 for us. If we check where we use this, for example, let's check it on chart. If we use this mint history on chart, we're gonna see that we use 100 limit and 0 offset. So we just fetch all this data for mint, for burn, and for transfer, and we're gonna aggregate this all in our chart. You can read this documentation, not documentation, like comments with this code. So for us, we gonna concentrate on mint data. Pay attention, we process chart data and we add all this mint and other data that we already get from our backend inside this chart. Like we aggregate this all, and then if it's not, we set chart data as empty array. Otherwise, we sort them by timestamp, we group them, and all events for each we create a time frame divider, and we do some conversion calculations for all this stuff. We're not gonna stop on this, and we set chart data as chart data array when we do all these calculations, and all is good. Like here we just calculate all stats, and when we add all this, we gonna get our set chart data and set stats. Stats, it's what we see below our chart, like these stats in global way. And in chart we're gonna see, like you see, we have these 2 mints, 1 mint, and 1 mint. It's 4 mint, happens by these time frames. These time frames, it's not fully like correct here, cause yeah, you see it's transfer and mints, and the total it's 6, but transfer is the same as mint, cause when you mint, you transfer some tokens, like in backend logic. So here you can delete it for frontend part, but we stay with this. I mean, if you check it like this, we're gonna see that it's yeah, by time it's a bit strange, like it's 19 days, but it just show me time. It can be fixed on frontend part, but like frontend part here is just some rudiment, you know. So for us, it's gonna be good for it. You can just change it to timestamp. Actually, give me a sec, I will do this. Okay, I did some fast fix for chart. Let's check now. We have 24 hours by time. It's logically correct, because in 24 hours we don't need days. In a week we're gonna have days. It's okay. Also we have January 2 and January 3. It's correct, yeah, because I tested it on this day and in this day, like 2 and 3 days ago. In 1 month we have this and this. It's also okay. And in 19 days we now have just weeks, not days. It's actually also correct, because too much days in this small chart otherwise. So it's okay now. I fixed it for you to use. Don't forget that you can just delete transfers if you don't need them, but we're gonna state like a good template for you. Maybe you're gonna use some another stuff there, not only mint and burn. Yeah, because you see transfers is the same as mint. We just like mint and we transfer simultaneously. Yeah, in our case. And for burn we don't have burns. Okay. Now in chart we do all this stuff. Let's delete this. We're not gonna use this now. And we actually do this mint in our interface already from backend. Like you see, by this example you can connect everything like this. And the last thing that I want to show you, it's a bit different, like it's not from backend but from our actual smart contracts. Let's change again to our minter switch. Let's update. Yeah, you see, after update it's better to like disconnect from one account and only have now def. It's actually, we don't need def. Let me change to recipient. Recipient, it's our minter. Yeah, because you see, when you have two accounts in Riovon, it's a bit buggy. Pay attention, it works for every applications like this. If you're gonna switch between accounts and update, it's gonna try to get your default account first, but it's just a Web3 pain sometimes. And now we as a minter, and let's try to mint tokens to this account. For example, recipient is not blacklisted. Recipient address, it's my def address. I'm gonna get, for example, free token. I hope I have RPC calls still. Let's try to do 3 and 4 tokens. Don't forget that it's 8 decimal, so I already write how it's gonna calculate it. We have transaction in Arbitrum Cipolla. Let's confirm this. And now confirm a transaction. It's okay, it's mean it's good. Let's check in activity. Let's change to recipient. And yeah, mean in January 5 it's happened. It's okay, we get some mint in our wallet. Let's update. Yeah, but we still don't see mints. You will ask why. Your interface is broken? Are you like stupid or what? If you check previous videos, we have subgraph. And we will back to this theme again, what I already explained. You see, in subgraph we actually synchronizing and indexing in real time. This mint happened now, but current blocks when mints happen is still like behind. So this transaction block that happened, it's still not our current block. You see, if we try to do mint here, yeah, I don't have mint saving. Let me actually call this mint. This means if we try to do this here, we can't see it's here either. You see, by amounts it's only 4 mints. And if we check transaction, let's check what block in this transaction is actually where this all happened. It's opened twice for me for some reason. Okay. In Arbiscan Cipolla it's happened on block 63, 463. Let's actually compare. And current block is 758. It's mean it's already should be. No, it's 70, 74, 63, and in our case it's 74, 21. It's a bit strange. I just saw 74, 74, 21. What the face happened? It's just like switching between itself, you know. Let's try to update this. It's just some subgraph application problems. 7421, and we have on 63. Yeah, you see, it's still not in our indexing, so we need to wait a bit. Let's try again to call this, and if it's still not there, I will just wait while it's indexing. And I need to save this trash, because it's a bit annoying to do it every time. Save. And yeah, it's still not here. Let's wait a bit. I will wait and we'll return to you in a sec. Okay, it's now 79:43. I didn't do a call because I want to do it with you. Let's check now. It should be new mint 2, and yeah, it's here 3, like 3 billion for blah 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 amount. I don't know even wanna like count this, but it's our current amount. It's our new timestamp, our new transaction hash. It's gonna be similar with this transaction hash here. Yeah, you see, it's the same. And let's close this. And yeah, now we go to our frontend part and let's try to update our frontend. What's gonna happen? Because our backend is actually get some error. What the fuck? Form address, we could not serialize to JSON method. Oh, okay, it's because I changed to string. Give me a sec. Oh yeah, just on backend side, this stupid slice here. It was all problem. It's when I did some refactoring. I didn't delete the slice fully. It's not our like big problem. It's just because I'm retarded and forget. So now it's okay. Let's continue. Now if we update, we gonna get our new mint there. You see, now our mint is a bit like different from our transfer. It's because of this serialization error, but still, for us it's even good because we can now separate mint and transfers. In ideal it should be mint and transfer the same, but for us it's separated now, so you see chart a bit different for mints, and it's our current mint. You see, it's all good, and even by weeks it's a bit different, but it's reversed a bit wrongly. December 28 goes after January 4. I'm not gonna fix this because I'm already wasted a lot of time. You can fix this and send a pull request to this. If you do this, I will subscribe to you on GitHub and you're gonna be good guy. Because this is a bit annoying for me to fix everything just in a video. But okay. Now we have mint here with 3.4 and you see mint is correct. It's mean it's working, and how it's working, let's do fast check how it's working now. We don't need actually Backend for this. It's happened on admin panel. In mint form we use this hook form, how I already show you in libraries, but we're not gonna concentrate on this hook form. We're just gonna see that it's a simple like transaction with comma contract mint, comma contract total supply. If we check what comma contract is just like instance of our efforts. Yeah, you see comma contract balance of, we get some balance, we get all this stuff from comma contract, and comma contract is just from our contract from use wallet. Use wallet is function from our context in wallet, and you remember if we check again this comma contract is set context, and set contract comma contract we get contract here from our contract address comma proxy, and our proxy we already added in our env example with the comma contract, you see, comma contract address. So for you it's mean that fuck, I close this. Seriously. Give me a sec, I will copy, find it again. No, I don't need backend. Jesus, where I was before this? I was on admin panel and I go to wallet context and in set comma contract I get this comma proxy. Yeah, it's in const, it's not in env. Sorry, I'm just a bit confused in all this code. I'm recording it in one day. It's in contract address because like env example you can just change it to your env example if you want, to your env, but in our case we just have a constant here with all these strict addresses. So it means we can get all this address for admin panel here, and actually we can do mint with just efforts functions. Like mint handles some mint and we handle mint. Let's check handle mint function, and in handle mint function we have this checkers, comma contract, signer and provider. It all should be, of course, because signer and provider like and contract, it's what we need for transaction. Wrong network, it's also to check if it's Sepolia. Minimal balance, pay attention, in my case minimal balance at arbitrum Sepolia it's 001, and then we get current balance, we compare this, and then we try actually do this stuff. We get amount that we gonna transfer. and we get some gas price from feed data. We call mint function from our comma contract. We just call it like this. You see, it's advanced method of calling. You just have your contract and you're calling it like this, not even with some ABI stuff like you already usually do in Ether. We just call it like this from comma contract with gas limit, and actually Ether we use only this for parse units. Yeah, you see. But parse units, it's like just parse this GWay to our actual units there to pay for gas and others, like to stay some limits on gas fee. And then we just set transaction hash if it's all good. Mint form is reset to get like it's gonna be deleted from input. Total supply is comma contract new total supply, set contract info, we just update contract info with new info. But in our case we have also backend REST API implementation, so we need to update page anyway, or like add here requests from backend side. In my case it's just requests from you see, from contract itself. But if you want, you can add also use token data requested here, like, and it's gonna fetch new data. And you see, it's all for us. It's like simple process. We just calling mint from comma contract mint, and we can use it with every other like with burn, with blacklist and other stuff similarly. Just like call it's from contract. You can check all these contract functions in previous video about smart contract. So it's all stuff that I want to show you in this video about frontend. I want to do it short one because like previous backend indexer subgraph and actual contract is a bit more interesting than frontend for me, because I'm a bit annoyed with frontend. It's my main specific job tasks to frontend. So it's all that I want to show you in here. You can ask me questions about all this stuff. It's final video about this comma flow, all this stuff in description, and guide is completed. You can send your pull requests, send your questions to me in private messages or in comments, whatever you want, and let's go.